right, y'all. School is in session, DJ Voltage on the 1 and 2s. We're about to break down the circuit.
I bet I can teach you the basics of wiring electric circuits together using nothing more than a 9-volt battery, some wire strippers, some holiday lights that were snipped into fragments of wire, and of course the bulbs from your holiday lights. I can use those basic materials to teach you how to be a pretty darn good electrician, at least knowing the basics of how to wire things together. So let's find out how we can do it, and we're going to show you some pretty cool stuff in this video. Let's start with the basics. Every circuit needs a voltage source. So for today's circuits, we're going to be using a 9-volt battery as our voltage source, but a voltage source could also be a generator, like something you would find at a power plant, or it could be a AAA, AA, a C battery, a D battery. It doesn't really matter. So I'm going to use a 9-volt battery for today's experiments. And every circuit also needs a conducting path. So that path could be wire, and it usually is copper wire. So I got my wire from holiday lights, and basically I just cut off all the segments of wire to whatever lengths that I want. And so your wire is going to be connecting from the positive terminal of the battery and back to the negative terminal. Now this wire is coated in a layer of insulation like most wire, and so I need to have some exposed copper wire here for this circuit to actually work. So what I can do, of course, is use my wire strippers. And the way these work is you're going to see a bunch of holes, and these correspond to different wire gauges, and they're labeled. So this one has gauge 10 through 22. And for wire gauges, actually the smaller the number, the thicker the gauge. So you're going to have thicker wire at gauge 10 here and thin wire at gauge 22. So what we need to do is figure out what gauge this wire is. And I think for this, we can just use trial and error. I'm going to stick it in the 14 gauge hole, pinch it and pull. And when I do that, you're going to notice that now I have exposed copper wire. So it looks like this is pretty close to 14 gauge wire. And so now that I have exposed wire on this end, I can do the same thing to the other end, stick it in the 14 gauge hole, pinch it and pull it, and I have exposed wire here. So technically, this is all a circuit needs. And so now electricity can flow from this end through the wire and back to the other end. But you would never want a circuit to look like this in real life because there just isn't enough electrical resistance here. So basically I need to add what's called a resistor, some device that's going to slow the flow of current. It could be a light bulb, or it could really be any other appliance that you're hooking up to your circuit. Today I'm going to use light bulbs, but you don't really want a circuit with just wire on it because you're going to get a ridiculously high flow of current. That's going to cause your voltage source to overheat, and it may cause an electrical fire. Okay. So what I really want to do is snip this wire, and maybe I'd basically do this. I'd have exposed wire on both ends here, and then I would have exposed wire on both ends of this one. And you can actually take wire. So if you have two exposed copper wires like this and you want to connect two elements together, you can just basically hold up the copper like this and twist it around itself. And if you twist it like this, you're going to get now this bulb connected to this wire. And of course, I can do the same thing here. If I want to connect these two exposed copper ends together, I can twist them with my fingers around each other. And now I have a light bulb connected to two pieces of wire. I can touch these to each end of my battery, and look at that, it lights up, right? So at a minimum, a circuit should have wire to conduct the charges, some kind of device to use that electrical energy. So in this case, a light bulb, and that's going to help slow the current down so things don't get super hot or catch fire. And then of course you need the voltage source, which pushes the energy through the wire. So there's a basic circuit. Now, most of the time when we build circuits, they have more than just one light bulb. So it's pretty rare to find a single resistor in a circuit. So I'm going to demonstrate one way to connect multiple light bulbs together. And that's the configuration we call series circuit. So series means one after the next. So if I take two light bulbs like so, and I just take their copper and I rotate them around each other, now I've tied two bulbs together. And so if I connect them to the battery, so I'll show that here, you're going to see that they both light up. So I have two light bulbs in series. And if I take a third one and I connect that to the end here, so I'll take this copper and twist it around the second bulb. Now I actually have three light bulbs that are all in series with each other. And so if I touch them to the ends, you're going to notice that they are all lighting up, but they do appear to be a little dimmer than they were with just one bulb or with two bulbs. And I could take a fourth bulb. So let's grab another here, and I can hook that fourth bulb up to the third one, twist them together. And now I have 4 light bulbs in series with each other. And remember, series just means one loop from start to finish. And if I take those 2 ends, so let me show this like this, and I touch those 2 ends to the 2 ends of my battery, they light up again, but they're pretty dim this time. So let me get a good viewpoint here. So much more dim. And that's because the more light bulbs I add, the more resistance the circuit has. And the more resistance the circuit has, the lower the current. So if I keep adding more and more and more light bulbs in series, it's going to get dimmer and dimmer and dimmer as that resistance goes up. So that's how you can build a basic series circuit. And of course, I could take like segments of wire if I wanted to increase the length of the circuit. I could tie the wire to that. And now I just have a longer circuit. It still functions the same. It's still 4 light bulbs in series. Or of course I could like break this open here, put another piece of wire there, and that's just adding length in different sections of the circuit. So it's also possible to create circuits that have a split in the circuit. So what I mean by that is, like, let's say this wire is connected to the positive terminal of the battery. And then from here, I want to split so that it actually goes in 2 different directions. So what I would do is I'd take all 3 of my elements and tie them all together in the same spot. So if I take all 3 of these wires and twist them together, oops, messed that one up. So let's twist them all together. Now what I have is, you can imagine electric current is flowing from the battery. It hits this node here, and then it splits, and now the current can go in 2 different directions. And that's useful because I may want to have a light bulb on this path here, and a separate light bulb on this path. So maybe instead of having the light bulbs in series, I want them in what's called parallel. So now parallel means, let me finish this circuit here and I'll show you a close-up. A parallel circuit means you have, and actually I'm going to add one last part here. There we go. So what separates a series circuit from a parallel circuit is this. If I show you this viewpoint here, now current is going to flow from the battery like so through the split, and some of it's going to go down. I'm going to flatten that out for you so you can see it better. Some of that current is going to go through the left path, and some of the current is going to go through the right path. So instead of these light bulbs all being in a series, we have a split here that's causing the current to go in 2 different pathways, and then it meets back together again and comes back to the battery. So what's the benefit of a parallel circuit? Well, I could add as many paths as I want, right? And if one of these light bulbs goes out in parallel, so let's say this light bulb burns out for whatever reason, it does not affect the other bulb. So if you consider that this bulb burns out, you still have current that's able to travel through the other light bulb. But when you had them in series, the problem with series circuits is if one light bulb goes out, all of the light bulbs goes out. So that's like not a very efficient way to wire things together, because if I had 100 light bulbs in series and just one of them went out, my entire string of holiday lights is now dead, and I have to go figure out which is the dead bulb. Whereas if I had 100 bulbs wired in parallel, so let's say I added a 3rd path and a 4th path and so on and so forth, if one of these paths goes out, it's okay because current can still flow through all the other paths. So this is a configuration that we call parallel circuits, very different than series. What do you see here? What I've done is I've built a nice big parallel circuit. It has the battery on its own path over here, and then the path splits. So you have one path going through this bulb, a second path with this bulb on it, and a 3rd path with this bulb. So you would say that you have a parallel circuit here with 1, 2, 3 light bulbs in parallel with each other. Now, again, if I wired them all in series, instead of having 3 paths like this, you would have 1 loop from start to finish with all 3 bulbs on it. So here's a very clear example of 3 light bulbs in parallel. Now I'm going to go ahead and touch to the positive and negative terminal of my battery, and I want you to see what happens here. So what do you notice? 2 of the bulbs are on and the 3rd one's out. So I did this to illustrate that we have a dead bulb here. And because I wired them all in parallel, I still have current that's able to flow through the first path, so it still goes through the first bulb. And current can also still flow out to the 3rd bulb here. And so losing this path does not affect the other 2. And that's the main advantage of parallel circuits, okay? And if we had them all in series and one of the bulbs died, all of the bulbs would have gone out because they're all in the same pathway. Aside from building a pure series circuit where everything is on the same path, or a purely parallel circuit like you saw before where everything's on its own separate path, it is possible to build a circuit that's called a combination circuit. And most circuits in real life are actually combination circuits. That means they have some characteristics of series circuits, but also some characteristics of parallel circuits. So let's look at this circuit here as an example. What do we see? How would we explain how things are wired together? Well, we have our voltage source here, and if we just follow from the start, we have one light bulb that then splits, and then that split has two parallel paths that come back together and then come back to the battery. So what can we say about this first light bulb? It comes before the split. It comes before every other bulb. So we would say that this bulb is in series with all the rest. But then what do we see? There's a split here, and so we have this bulb is on its own path, and that path is parallel to this other path that has three light bulbs on it. Well, how are these three light bulbs wired in relation to each other? If you just look at this path here, you could say that there are 1, 2, 3 light bulbs in series with each other, and those three in series are parallel to this other light bulb that's on its own path. So basically, we have one in series, then there's a split with two parallel paths. One path has a single bulb, and the other path has three in series. So this is definitely a combination of both series and parallel. This is an example of a combination circuit. So now when I touch both wires to my battery, what do we see? Well, it looks like that first bulb that's in series with everything else is much brighter. And then the one in the middle, or the one that's on its own parallel path, is pretty bright, or medium brightness. And then these three, it's really hard to see probably through the camera. They're all on, but they're very, very, very dim. And so we're getting three very different brightnesses: very bright, medium brightness, and so dim that they almost appear to be off. So why is that? Well, this is what makes combination circuits interesting. And so if you think about the flow of charges, which we call electrical current, there's 100% of the current from the battery is flowing through this first bulb. It has to. There's no way to get around this bulb. So if this bulb is getting 100% of the current, that means it's going to be extremely bright, as you saw. But then what happens? The current reaches this node and splits. So some of the current is going to go this way, and the rest of the current is going to go out through these three bulbs. And so that means both paths are receiving less than 100% of the current. So there's no way these bulbs could ever be as bright as the first bulb. But what do we see on this left path here? Or I guess from your point of view, the right path. Well, this has only got one bulb on it, so there's not that much resistance on that path, which means there's a pretty good amount of current that's going to come this way, and that's why this bulb was relatively bright. Now, what's out here? We have three light bulbs in series. And remember, if there's more than one bulb in series, there's going to be more resistance, which means the more resistance you have, the less of the current is going to want to flow this way. So when it splits, it's not a 50-50 split. More current goes down the path with one bulb, which makes it brighter, and less of the current wants to go down the path with three bulbs because there's just too much resistance there, and that's what makes them so incredibly dim. So how could I make these appear to be a little bit brighter? Well, first of all, let me show you what they look like now. Hard to see that they're on. I could take a bulb off this path so that it only has two bulbs on it, and when I do that, I've reduced the resistance on that path. So now let's see if more current will go down that direction. Still pretty dim. So it's hard to tell that they're really on. I can see it, but maybe you can't. And so really, to make that path as bright as the other path, we really have no choice but to get rid of all of those bulbs. So let's try it again. And there, now you can see they're a little bit brighter, but not that bright. This one actually got dimmer because now the current's going to split 50-50. It used to get more than 50% when there were more bulbs here, which made it brighter. But now that both paths only have one bulb, the current does split 50-50. And so they're getting, this one's getting a little less than it used to get. And now they're relatively dim, but I think a little bit brighter than that path used to be before, okay? The beauty of combination circuits is that the possibilities are virtually limitless. And actually, if I had just three light bulbs in a circuit, like you see here, 1, 2, 3, There's exactly 4 ways to wire 3 light bulbs together. You could have all in series, that's one way, all in parallel, which is another way. And then this is the 3rd way, which is 1 in series and then a split with 2 in parallel. And then the 4th way to wire 3 light bulbs together would be simply to, let me twist these together here. You would add a light bulb on one of these paths. And so it would look like this. Give me just a second. So this is a circuit that has none in series, but really it's just an immediate split at the start that has 2 on one path and 1 on the other path. So like I showed you before, there's exactly 4 ways to wire 3 light bulbs together. And if you had 4 light bulbs, just increasing your light bulbs by 1, there are 10 different ways to wire 4 light bulbs together. So how many different ways do you think there are to wire 5 light bulbs together? Well, maybe add your guess in the comments section. Let's see if you guys can come up with that. Remember, there were 4 ways to wire 3. There's 10 ways to wire 4. So it doesn't increase linearly. There's actually sort of an exponential curve that happens. So how many different ways can you wire 5 light bulbs together? Let me know what you think. I'd love to hear your thoughts on the matter. So anyway, I could keep adding bulbs. I could add more at the beginning. I could have some at the end. And you can make predictions like which ones will be brighter, which will be dimmer. And that all depends on, where they are, right? If you have one that's near the beginning, it's getting 100% of the current, so it's going to be brighter. And even if you put one at the end, so let's say I added a light bulb right at the end, right before it hits the battery. Well, I know that when this current splits here and comes back together, now this light bulb is also getting 100% of the current because 100% has to leave the battery and 100% has to return. So any light bulbs that are before or after the splits are getting the most current and tend to be the brightest. And the ones on the pathways will be dimmer, and whichever path has more bulbs is going to get less current, so you get dimmer bulbs on this path. And then whichever path only has 1 bulb on it would be brighter because it's getting more current. So what did we learn today? We learned about the difference between series and parallel circuits. Remember, in a series circuit, all of the elements in the circuit, say for example light bulbs, are wired in series one after the next, from the positive terminal and back to the negative terminal again. You're going to notice that they're all in a single loop from start to finish. A parallel circuit, recall, they had all the different components were on their own separate pathways. So that means that from the battery, there has to be a split with at least 2 different paths that come back together again. And then of course, we learned about combination circuits, which are circuits that are more complicated because they have elements of series involved as well as parallel. And remember, with combination circuits, your imagination is the limit. You can come up with all sorts of different ways to wire things together. And depending on how you wire them, you're going to get different results, different brightnesses and different effects. When one bulb goes out, do the others go out too, or do they stay on? It all depends on how you wire them together.